Hello, good evening, everyone. Good evening. So, if you can hear me well, we can start tutorial number 7, the remaining questions to look at. I hope you are getting better at this chemical calculation story, right? So, can you hear me well? If you can hear me, I think we start with question number 9, tutorial number 7, question number 9. This is tutorial number 7. So, we look at question number 9. Question 9. Question number 9. Okay. I hope you can see the screen well. Yeah, everyone? Okay, right. Very good. Let's read the question. Question number 9. Yeah. Okay, right. Good. 13.2 grams of iron 3 alum. Alum is a aluminium containing salt. It's like commonly called alum, right? Doesn't matter. It says iron 3. That's all you need to know. So you have a sample which contains Fe plus 3. Fe plus 3, right? Now you are using 13.2 grams of this. 13.2 grams of this. Right. Then what you do is, this was dissolved in water. Right. So dissolved in water. When you add water, what you have is, you have Fe plus 3. Right. You have Fe plus 3. That's what you get. You have Fe plus 3 ions. Iron 3 iron. Was and reduced to iron 2 solution by adding zinc. So you add zinc here, right? So you're adding zinc here. Zinc is a den plus is a den zinc, zinc, and it is reduced to Fe plus 2. Fe plus 2 in dilute sulfuric acid, right? The mixture was filtered, and the filtrate and washings made up to 500 milliliters standard volumetric flask. So you filter it. When you filter it, what you get is you have Fe plus 2. And this Fe plus 2 solution, you make it to 500 milliliters by adding water. 500 milliliters by adding water. 20 milliliters of this solution, from this solution, you take 20 milliliters. From this solution, you take 20 milliliters, right, into the titration flask. And 0.01 molar potassium permanganate. 0.01 molar KMnO4. Potassium permanganate, you need 26.5 milliliters. For the titration. For the oxidation, this Fe plus 2. Now you have Fe plus 2. This Fe plus 2 needs this amount of potassium permanganate for the oxidation. So what they ask is, write the ionic equation for the reduction of Fe plus 3 ions by zinc metal. Calculate the percentage mass of iron in the iron alum. Right. Now, if you don't understand anything here, you need to tell me immediately before doing the calculation. Right. So, Fe plus 3 is there. Fe plus 3. You are adding zinc to it. Is that it? Zinc turns into zinc plus 2. Zinc turns into zinc plus 2. And it says Fe plus 3 turns into Fe plus 2. Fe plus 3 is reduced, zinc is oxidized. That's all. Right? Now what you can do is you can balance this equation. Fe plus 3 turns into Fe plus 2. So 1 electron. Here zinc turns into zinc plus 2. 2 electrons. Multiply this by 2. This is 2. This is 2. 2 times 3 is 6. 2 plus 4 is also 6. Right? Did you understand that? Everybody? So Fe plus 3, when you take Fe plus 3 and you add zinc powder to it, it turns into Zn plus 2. It will oxidize. Fe plus 3 turns into Fe plus 2. Right? So this is reduced. Now you have Fe plus 2. right? So this is what you have here. This is what has happened there, right? What you do is now you take this into 500 milliliter solution, 500 milliliter solution, right? And then out of that you take 20 milliliters and you titrate it, right? So this is the reaction for the reaction with zinc. This is the reaction for the zinc. Fe plus 3 is oxidized, zinc is turning into zinc plus 2. Now, what you have is when you filter it, you get zinc Fe plus 2. So Fe plus 2 now get titrated with potassium permanganate, right? So it reacts with KMnO4. Can you write the reaction here? Fe plus 2 and permanganate reaction, can you write it? So Fe plus 2 and permanganate in the acidic medium turns into what? Because it is acidified in sulfuric acid. This is done in the acidic medium. Fe plus 2 turns into ferric. Now zinc is not there because it is filtered. Permanganate turns into Mn plus 2. Right. See whether you can write down the reaction. So Fe plus 2 to Fe plus 3, 1 electron. Permanganate is plus 7. Plus 7 to plus 2, this is 5 electrons. You multiply this by 5. This is 5. This is also 5, right? Manganese is balanced already. You need to add water, 4 water molecules, 4 times 2, you get 8 H plus. Here it is 8 H plus. Did you understand that? Right? So that reaction takes place. This is the oxidation. With permanganate, the oxidation reaction takes place. Is it clear? Did you understand those two reactions? Everybody? Yeah. Aditya, did you understand those two reactions? Tell me whether you got it. Everybody? Right. So now what you do is, right. So now based on that, you can look at the stoichiometry. So this stoichiometry is based on these two. This is what you need to connect. This is what you're trying to find out. This is what you know. So number of moles of Fe plus 2 divided by number of moles of permanganate, MnO4 minus, is equal to what is that? 5 divided by 1. So number of moles of Fe plus 2 is equal to 5 times permanganate. 5 times permanganate is, what is that? 0.01, 26.5. 0.01 times 26.5. 10 to the power minus 3. Clear? Did you understand that? So what is that? 5 times 0.01 times 26.5, 10 to the power minus 3 is equal to 1.325. 1.325, 10 to the power minus 3 moles. Did you understand that? That is the number of moles. So that number of moles was present in 20 milliliters. Look at this one. Look at the laser pointer, 20 milliliters. But the original sample is 500 milliliters. So I'm going to calculate it for 500 milliliters. So number of moles of Fe plus 2 in 500 milliliters. What is that? 1.325, 10 to the power minus 3. This is present in 20 milliliters. What is the amount present in 500 milliliters? Moles. So this and this cancels out. This is 25. So that value is multiplied by 25 is equal to 0.033125. 0.03312 moles of Fe plus 2. So if the number of moles of Fe plus 2 is this much, number of moles of Fe plus 3 is also same amount because the stoichiometry is 1:1. If this is 5, this is also 5. Right? You can see if this is 2, this is also 2. Whatever the number of moles of Fe plus 2 present, same number of moles of Fe plus 3 present as well. So this is the number of moles of Fe plus 3. is equal to that. Calculate the percentage by mass. So how do you calculate the mass? Mass is equal to the number of moles times the molecular mass. What is that? 0.033. I don't want this number of decimal places. Multiplied by molecular weight or atomic weight is 56. So what is that? 0.033 times 56 is equal to 1.848. 1.848 grams. Now, what do they ask? They ask you to calculate the percentage. Percentage mass. What is the percentage mass? 1.848 grams divided by total number of mole, total grams is 13.2 grams multiplied by 100%. Right? So you get grams and grams cancels out and you get the percentage. Divide by 13.2 multiplied by 100%, you get 14%. That's how you get the 14%. If there is no acid added, this reaction won't happen. No, it doesn't happen. It is happening in the acidic medium. That is why it says there dilute sulfuric acid was added, right? Just to acidify the sample, right? Is it clear? Right. So that is your question. That is it. Question number 9 is that. Very simple question. I hope now you have been doing this for a long time. Like, you only thing that you can do is you can get better. That's the only thing that can happen. Right? Okay. Is it clear? Everybody understood that? Very good. Everybody understood that? Right? If you don't have any further questions, do you have any questions here? If you don't have any further questions, I can go to the next one. Right? If you have questions, you need to tell me. I did using Fe plus 2. Fe plus 2 तो मैं नहीं. Fe plus 2 is the number of moles. The Fe plus 2 is the one that is reacting. But they ask you to calculate Fe plus 3. Fe plus 2 and Fe plus 3 both are the same. Right. Okay. So if you are okay with that, now many people say that they are okay with it. Right. Right. Okay. Right. Question number 10. Question number 10. Right. So let us write it down. Right. Let us look at the question number 10. Calculate the concentration in moles per cubic decimeter, grams per cubic decimeter in salts of sodium ethanoate, dioate, sodium oxalate solution. 5 cubic centimeters of which oxidize in acid by 24.5 potassium permanganate solution containing 0.05 moles per cubic decimeter. Now, you have done the reaction. You know this is oxalate C2O42 minus C2O42 minus with permanganate ions MnO4 minus. C2O42 minus turns into CO2, permanganate turns into Mn plus 2. Right. This is plus 3, this is plus 4, 1 electron. So that means you have 2 electrons to participate in oxidation. Plus 7 plus 2, you have 5 electrons participating in oxidation. Multiply this by 2. So this is 2, this is 2. Multiply this by 5. When you multiply this by 5, like higher number of atoms, you multiply by 5 first. 5 times 2, 10 carbon dioxide. In order to balance the charges, 10, 12, 16, you add 16 H plus to this side. In order to balance hydrogen, you add 8 water molecules. Right? So that's your reaction. Is it clear? Everybody understood that reaction? Right? Can C2O4 can go to oxygen? C2O4, now we have been doing this for a long time. Then it always goes to CO2, nothing else. It doesn't turn into anything else, right? It turns into CO2, right? Calculate the concentration, 5 cubic centimeters, which was oxidized by 24 milliliters of 0.05. So this concentration is 0.05. 0.05 molar. Volume is 24.5 milliliters. right? Okay. So now what is this? Number of moles of oxalate, C2O4 2 minus, to number of moles of permanganate, MnO4 minus. What is that? Oxalate is 5, permanganate is 2. So what is the number of moles of oxalate? C2O4 2 minus is equal to 5 divided by 2 permanganate, 0.05 times 24.5, 10 to the power minus 3. Right. So what is that value? 5 times 0.05 times 24.5 10 to the power minus 3 divided by 2 is equal to 3.06 10 to the power minus 3. 3.06 10 to the power minus 3 moles. So this is the number of moles of oxalate ions. Right. Sodium oxalate solution 5 milliliters, which was oxidizing acid. Right. So this was presenting 5 milliliters. So what is the concentration? Concentration of oxalate ions is equal to, what is that? Number of moles divided by volume, 3.06 10 to the power minus 3 divided by 5 10 to the power minus 3 moles per cubic decimeter. This and this cancels out and you get, what is that? 3.06 divided by 5 is equal to 0.612, correct? 0.612 moles per cubic decimeter. Is it clear? Everybody got that? All of you? Ah, right. Everybody okay with that? 0.612. Then it says calculate the concentration in grams per cubic decimeter. So you have to convert this into grams per cubic decimeter. 0.612, convert it to grams. How do you convert it to grams? Sodium oxalate 46, carbon 24, oxygen is 64, 134. So multiply by 134 grams per cubic decimeter. This is the molecular mass of sodium oxalate, Na2C2O4. That's all. Very simple thing. 0.612 multiplied by 134 gives you 82.008 kilo. So 82 grams per cubic decimeter. Is there any problem here? Anything that you didn't understand or anything you want me to explain further? Anything, right? If so, you can ask. Otherwise, we can go to the next question, right? Is it clear? Right. But only the last part. Only the last part means, this is what you have. Okay, very simple thing. Right? Right? Only the simple thing, right? What you do is, you take this concentration, you multiply by the molecular mass because you want to convert it to grams. Sodium oxalate, Na2C2O4. What is the molecular mass? You get it as 134 molecular mass. Is that 82 grams per mole? 82.008. You round it off to 82. You don't consider 008. I think that is okay. Harinda, is it clear? Anything else? Any other question? Yeah. Right. Well, and when we can also find it by converting moles to grams and then dividing by volume. But then you can't calculate the concentration, right? Right. Okay. How did you get grams per mole? Isn't it grams per moles? No. Grams per moles. Grams per cubic decimeter. Right? 0.612. Moles per cubic decimeter. Right? Multiplied by 134 grams per moles. You're multiplying by the molecular mass. What a moles and per moles cancels out, you get grams and cubic decimeters. Work with units, huh? So 82. Is it clear? What is that? 134 is the molecular mass, yes. Alright, that's okay now. When you are explaining, it seems very easy, but when you are trying, it's hard. You have to keep on trying. හරිද මේක ට්‍රාට් අපි try කරන්න ඕනේනේ, right? Okay, yes, so keep on trying. ඒක පොඩ්ඩ try කරන්න ඕන, right? Okay, right, go to the next one, question number 11, right? Question number 11, right? I will write the question number 11, right? Okay, let us work on this now. Okay, right. 134 is the relative molecular mass. You have to convert it to grams. Molecular mass is not the relative molecular mass. It's the molecular mass you multiply with, right? Grams per mole. 1 mole contains this amount of grams. Right? Don't get confused. Huh? Question number 11. Let us work on question number 11 now. Calculate X in the formula ferrous sulfate XH2O. So work it out. Ferrous sulfate XH2O. Right. Following data. 12.18 grams of iron 2 sulfate crystals. This entire thing is 12.18 grams. 12.18 grams. Was made up to 500 milliliters. We have to make it to 500 milliliters. Acidified with sulfuric acid. So this is in the acidic medium. Right? 25 milliliters of this solution. So you are not going to use that entire thing. You are using only 25 milliliters. Right? Required 0.01 molar potassium permanganate. How many milliliters? 43.85. 43.85 milliliters. Answer is X is equal to what they say. It's X is equal to, we have to calculate it and see. Right. Okay. So let us see whether we can do it. Now, water doesn't react with potassium permanganate. Fe plus 2 is the one that will react with potassium permanganate. So we write the reaction with that. So we write that reaction Fe plus 2, with permanganate, MnO4 minus. Now you all know how to write that reaction. It turns into Fe plus 3. Permanganate turns into Mn plus 2. Right? So here Fe plus 2 turns into Fe plus 3, 1 electron. Plus 7 to plus 2, 5 electrons. Multiply this by 5. Right? And then in order to balance this, you need to add 4 water molecules. 4 times 2, 8H plus. So I'm going to slowly remove this, try slightly move this here. And then write it as how many water molecules? 8H2, 4 times 2, 8H plus. 8H plus. Little difficult because I have a little bit of space there. Right. Okay. So the reaction is, you're okay with this reaction. You know how the reaction works. Right. Okay. Let's look at the number of moles of Fe plus 2. Number of moles or reaction. Then the next thing that you need to do is you need to look at the stoichiometry. Don't write anything. Permanganate. So Fe5 permanganate is 1. Number of moles of Fe plus 2 is 5 times permanganate. What is that? 5 times permanganate is 0.01 times 43.85. 10 to the power minus 3 moles. Right. So let us get the value. 0.05 multiplied by 43.85, 10 to the power minus 3 is equal to 2.19. I am not going to go for that decimal places, right? 2.19, 10 to the power minus 3 moles. This is the number of moles that is present. That number of moles present, look at the laser pointer here. Number of moles was present in 25 milliliters, but the total solution was 500 milliliters. So we need to calculate that. So number of moles of Fe plus 2 in 500 milliliters. In 500 milliliters. How much is that? 2.19, 10 to the power minus 3 This was present in 25 milliliters. What is the total amount in 500 milliliters? So the unit is moles. 25. This is 20. So what is that? 2.1925 multiplied by 20 is equal to 0.04385. 0.04385 moles. So this is the number of moles of Fe plus 2 present in this sample. Right. So if you have that, right, now you know that the number of moles. If you know the number of moles, I think we can calculate the molecular weight. You know the weight here, you know the number of moles here. So number of moles is equal mass divided by molecular mass. So therefore molecular mass is equal to mass divided by the number of moles. What is the mass that you have taken? You have taken 12.18 grams. 12.18 grams. The number of moles is 0.04385 moles. Right? So 12.18 divided by 0.04385. 277.76. 277.76 kilon. The molecular weight. Now I think we can calculate the number of moles of water. Fe is ferrous sulfate. Ferrous sulfate XH2. Iron is 56. Sulfur is 32. Oxygen is 16. 16 times 4, 64. Plus water is 18x is equal to 277.76. So what is that? 56 plus 32 plus 64. 152. 277 minus 152. 125. Divide by 18 gives you 6.94. X is equal to 6.94. So 6.94 you can't have fraction values. It should be an integer. So that is roughly equal to 7. So therefore this is ferrous sulfate 7H2O. Right? Ferrous sulfate 7H2O is your answer. Check whether you got that thought. 12 grams of only with iron sulfate crystals, or is it together with water? It's together with water, everything. Ferrous sulfate crystals means ferrous sulfate, XH2O, everything together is 12.8. Right. Right. Good. Right. You have to get it. That way, concentration, these these calculations, make sure to do it. Because later on in physical chemistry, there are kind of simple calculations that you need to do next year. Where year lamai ගොඩක් upset කරගන්න because they don't do this. මේක හරියට කරන්නේ නැහැ. I got it as 6.7. හරි කමන්නේ. 6.7 කියන්නේ පොඩි කොහේ හරි calculation එකේ පොඩි upset එකක් ඇති. That's okay. ඒකින්ද මේක very patiently do these questions. එතකොට තමයි ඔයාට මේ concentration calculations you get it. හරිද? එතකොට when you come to that level next year, it will become very easy. Right? I now, sometimes I see students are a body concentration because they have never been working this when they want to really work. Right. Okay. Right. So question number 11 is okay. Everybody, I hope all of you are okay with question number 11. Right. Right. Let us look at the next one. Try question number 12. Right. Given the half reactions, these reactions are given. Given the ionic equation, potassium permanganate oxidizing nitrate 3 to nitrate 5. And plus 3 oxidation state, plus 5 oxidation state. So don't look at that. Mama like don't look at it. You try to balance on your own. What skill again, right? Try to balance on your own. Even though the answer is there's some given there, try to balance it. This is what you have, the nitrate, NO3, NO2 minus, right? NO2 minus plus permanganate. MnO4 minus, turning into NO3 minus, plus Mn plus 2, right? This is plus 3 oxidation state. This is plus 5 oxidation state. You know 2 electrons. 2 electrons. This is plus 7 oxidation state. This is plus 2 oxidation state. Here you have 5 electrons. Multiply this by 2. Multiply this by 5. How many? 5. Make a 5. Multiply this by 2. This is 2. Multiply this by 2. Now let us look at the charges. Right? What is the charge? Plus 5, minus 5. They cancel out on both sides. So 2 times 2, 4, minus 2, that means you need to add 6H plus onto this side. If it is 6H plus, you need to balance. This is the only place you have water. 3 water molecules. Check whether oxygens are balanced. 5 times 2, 10. 2 times 4, 18. 8. 8 plus 10, 18. 5 times 3, 15. 15 plus 3, 18. Now it is balanced. Did you understand that? Right? Is it clear? Did you understand that? Did you understand how to balance it? Did you get the balanced equation? Show me your hands if you got the balanced equation right. Even if you copied it from the material. Did you get it? Right, good. You have been doing it. Okay, I think everybody should do it. Okay, tika, you become better at it. And it will help in the long run. Right? All right. Okay. So let us look at this one. Give the ionic equation. 24.2 gram cubic centimeter sodium nitrate solution. Make, right? So this solution, how much? 24.2 milliliters. Added to a burette where needed to discharge the color, right? Of 25 milliliter acidic potassium permanganate solution. Water, you have 25 milliliters acidic potassium permanganate solution, acidified 0.025, 0.025 molar potassium permanganate solution. What is the concentration of nitrate in grams of the anhydrous salt per cubic deciliter? First of all, don't get excited with when they say concentration, you find it in moles. You can turn this into grams, right? Okay. So what is this? Number of moles of nitrite ions to number of moles of permanganate. Right? So what are those numbers? Is equal to how much? Nitrite is 5 and this is permanganate is 2. So what is the number of moles of nitrite ions? NO2 minus is equal to 5 divided by 2 permanganate 0.025 times 25 10 to the power minus 3 moles. What is that? 5 times 0.025 times 25 10 to the power minus 3 divided by 2 is equal to 1.565. 1.5625 10 to the power minus 3. Right? So now you find the concentration because it's 24 milliliter, 24.2 milliliters are there. So concentration of the nitrite, you can say sodium nitrite. So what is that? Number of moles divided by volume. 1.5625, 5625, 10 to the power minus 3 moles. Moles are the minus. Divide by volume is 24.2. 10 to the power minus 3 cubic deciliters. So you can see this 10 to the power minus 3, 10 to the power minus 3 cancels out. 1.56, 1.5625 divided by 24.2 is equal to 0.0645. 0.0645. The unit is moles per cubic deciliter. Right? Okay. So what do they ask? Now read it. grams of anhydrous salt per cubic decimeter. So grams, not moles, they want the grams. What is the molecular mass of sodium nitrate? 23. Nitrogen is 14. 16 times 2, 32. 23 plus 14 plus 32 gives you 69. 69 grams per moles. Now you multiply, right? Convert moles into grams. 0.0645 multiplied by 69. Now it is grams per cubic decimeter. Moles cancels out. Multiplied by 0.0645. What you know? 4.45 කියලා තමයි එන්නේ. 4.4505. 4.4505 grams per cubic decimeter. Did you understand that? බලන්න. Isn't it nitrate? Nitrate නෙවෙයි nitrite. Nitrate plus 3 oxidation state. මෙතන තියෙන්නේ oxidation state එක plus 3. මේ X plus minus 2 times 2 is equal to minus 1. X is equal to plus 3. It says plus 3. Nitrate plus 3 oxidation state. Other one is nitrate plus 5. That's also another way of explaining the compound by looking at the oxidation state. Is it clear? Did you understand that? Right, okay. The question given as nitrate. කොහෙද පුතා තියෙන්නේ? කොතන තියෙන්නේ nitrate? Nitrate එක, that is, they both are given as the reduction. Read the question and get the actual reaction. Right? Permanganate undergoes reduction. Nitrite undergoes oxidation. Even though the reaction is given, they are both in the reduction form. They are both in the reduction form. You have to figure out what is the thing that is undergoing oxidation, what is the thing that is undergoing reduction. I am able to balance using redox easily, but there were half reactions in questions. How do you use them to balance the equation? If permanganate undergoes reduction, nitrite undergoes oxidation. That's all. They add them together like half reactions. Okay, right. So do we have to find the concentration of nitrate or sodium nitrate in the question? I think sodium nitrate, right? So because if you look at sodium nitrate, right? A box of chocolates. You have one box of chocolates, you have one nitrate. So if you have how many nitrite ions, same number of sodium nitrate present. Right? Number of moles of sodium nitrate is also the same. If you count the number of nitrite, you get the same number of moles of sodium nitrite as well. Is it clear? You have to convert it to sodium nitrate. Solution in grams of anhydrous salt. Right. Okay. Did you understand that? Everybody? No, Buddha. But the sides of the seams, never. No. You haven't got the problem yet. But now if you look at this one, the one that is given is nitrite plus 2H plus 2 electrons, giving you nitrite and H2O. That's the first reaction. Second reaction is permanganate and then 8H plus 5 electrons, giving you Mn plus 2 and then 4H2O. They are both given in the reduction form, right? But what is the actual reaction taking place? What is the actual reaction taking place? This is the actual reaction. Permanganate undergoing Mn plus 2. If this is undergoing reduction, this should undergo oxidation. So you need to write that reaction in the other way around, right? You need to turn that reaction in the other way around. Do you understand that? Because it says nitrite turning to nitrate. So you have to turn that reaction. You have to convert that reaction onto the other way around. So if when you're converting it, NO2 minus plus H2O, giving you nitrate NO3 minus plus 2H plus 2 electrons. That's the reaction that you do, that you write. Because you can't have both of these reactions taking place in the right. We know both of these not reactions are not taking place in the same direction. One is undergoing oxidation, other one is undergoing reduction. Right? Now you have to convert, you have to turn this in the other way around. And then what you do is you multiply this by 5, right? Now usual redox, and multiply this by 2, right? Now you have to understand that all the questions are not given in the same pattern, right? You use a logic, and you use that logic into a new system. That's the most important thing, right? Right. Okay. Right. If there is a slight difference in your answer, that is not a problem. Huh? Don't worry. Right. Don't worry. The most important thing is you're getting that very, very close to that answer. Right. 4.45, 4.45. If you have 4.45 plus or minus zero point 0.2 is all right. Right. For every answer, if there's a slight deviation, it's all right. Because now I do the calculation using the calculator. Now you all are doing by hand. Sometimes you don't go for the very edge of the decimal places, right? So I try to give the most accurate answer here. So if you can come closer to that answer, and if the answer is right, if you can come closer to that answer with a little deviation, that's all right. Don't worry about that, because you have done all the things right. You have done the equation right, you have done the concentration dilutions right, and the calculations is right, everything is, and then there's a slight difference in the final answer. I don't want you to worry about it. Right? Okay. Like, let us go to the next one. Right? Part B was, that is part B. Question part A, that is question number 12 is done. Question number 13, right? 13. Question number 13 is actually this is not the same exam question. This is a question that I have given earlier, but there has been questions like this in the exam, MCQs as well as essay, right? MCQs and as well as essay. So we'll try to focus on that and try to get it right. Huh? Okay, let's see. 2.68 of the salt of iron to ethane dioate. So listen to this very carefully. Yeah? FeC2O4, ferrous oxalate. 2.68. 2.68 grams. Was made up to 500 milliliters. 500 milliliters by adding acid. Acidified aqueous solution. That means it is done in the acidic medium, right? 25 milliliters of the solution is completely reacted. You take 25 milliliters of this solution, 25 milliliters of this solution, and completely reacted with 28 milliliters of 0.02, 0.02 moles per cubic decimeter potassium permanganate, KMnO4. Right? Calculate the molar ratio of taking place in the titration, write the balance equation and justify your answer. Right? It doesn't ask you to calculate volumes or anything like that, but they ask you to write the balance equation. Right? So how do you write the balance equation? There are two things that are undergoing oxidation. FeC2O4. Now you all know ferrous undergoes oxidation to ferric. Oxalate undergoes oxidation to carbon dioxide. Right? Always that. And ferrous undergoing oxidation to ferric. Oxalate turns to carbon dioxide. Right? Let me take this to this corner and then write Mn plus 2 also. Right? And then I'll write Mn plus 2 as well. Mn 2 plus. Right. Okay. Let's see how this is going to be done. Okay, Fe is plus 2. Plus 2 goes to plus 3. So this is oxidation. So I'm going to use the black color to do that, right? So 1 electron here. This is oxalate is plus 3, carbon dioxide is plus 4. Plus 3 to plus 4, right? Plus 3 to plus 4, how many electrons? 3 to 4 is 1 electron, but there are 2 atoms. So you have 2 electrons. All together, it gives you 3 electrons. They are both undergoing oxidation. Both of them undergoes oxidation at the same time. Fe plus 2 turns into Fe plus 3. Carbon in the oxalate turns into CO2 plus 4, plus 3 to plus 4. Altogether 3 electrons. Permanganate, it is plus 7 to plus 2. So plus 7 to plus 2 means you have 5 electrons. Now need to multiply this by 3, right? Need to multiply this by 5. If you multiply this by 5, look at this one, pay attention, right? If you multiply this by 5, you have to multiply this by 5. So I'm going to write that, 5. If you multiply this by 5, you have to multiply this also by 5. Why? Because in order to balance the mass. If it is 5, this is also 5. If you multiply this by 5, 5 times 2 is carbon. I'm looking at carbon. 5 times 2 is 10. So carbon dioxide, you have to have 10. When you multiply this by 3, that means you have to multiply this by 3 and this by also 3. Now let us look at the charges. Balance charge. What is the charge in the left hand side or right hand side? 5 times 3, 15. 15. 3 times 2, 6, 21. Plus 21. What is the charge here? The charge is minus 3. Minus 3. So in order to convert minus 3 into plus 25, you have to add 24H plus. Did you understand that? Yeah, that's plus 24. 24 minus 3 is equal to plus 21. 24H plus, if you add 24H plus, that means you need to add how many water molecules? 12 water molecules. 12 water molecules. That gives you this entire reaction. Now what they ask is, they ask you to get the balance equation. What is the balance equation? Write the balance equation, justify your answer, calculate the molar ratio of permanganate, number of moles of permanganate to number of moles of oxalate. Number of moles of ferrous oxalate. Clear? Permanganate is 3, oxalate is 5. That's it. Haridha, did you understand that? Everybody? Did you understand that? Everyone? Is it clear how to balance this kind of a thing? Here, like, rather than writing it in a multiple number of steps, you try to write the balance equation in a single step. What a mara velawak ituru karanna puluwa. Because others are struggling with multiple number of steps, and like you can balance it in a single step. How to justify your answer? You think, Metin, 3 and 5. You write the stoichiometry. When you write the balance equation, the answer is justified. Can't we neglect the spectate ions of ion Fe? Fe is not a spectate ion. We think that Fe is a spectate ion. No, it has participated in the reaction. Plus 2 has turned to plus 3. It has participated in the reaction. If it is just a spectate ion, it is just watching without changing the oxidation number. Here, the oxidation number has changed. Right? Did you understand that? So the answer comes with two things. This is the stoichiometry and this is the balance equation. Everybody okay with that? Right. Then why have they given the volumes and the concentration? You think they haven't asked the concentrations to calculate? They have given it. I think. You like you have a lot of information in that is the role in science. There are so many information that you can gather, but you answer the question. If they ask you calculate the concentration, then you can do this. But this one, there hasn't been in question. There might be so many information, but as a good scientist, you select the right things that is needed and bring a answer to the question. Did you understand that? Everybody okay? Is it clear? Right? Okay. That is okay. That is all right now. Question number 13 is done. Right. Shall we look at question number 14? We have a little bit more time. Finish this. Right. Question number 14 here. Right. Read the question in question number 14. Let's try to write that answer. Given the half reactions. Now they are given in the reduction form. You have to use the right form. You have to convert. One of these will be oxidizing. The other one will be the only thing that is undergoing reduction. You have to turn this. So deduce the redox reaction iodate ions to oxidize iodide ions to iodine. Right. So iodate. So IO3 minus turns into iodine. Right. So let us balance it. Make a half. 3H2O. 3 times 2, 6H plus. 6H plus, how many electrons? You have 5 electrons. I minus turns into iodine as well. It says iodide ions to iodine. Iodide to iodine, right? 1 electron. Multiply this by 5 and add them together. 6H plus iodate 5I minus 5 plus 1 is 6 divided by 2 is 3 iodine and then 3H2O. 1. Even though they are both given in the reduction form, according to the way that they have given you, you have to convert. You have to turn this, right? Left hand side to the right hand side, then you get it there. Reduce the redox. What volume of 0.02 iodate solution reacts with 20.1 molar iodide ion solution? Right, okay. So what is that? Number of moles of iodate to number of moles of iodide. Here, 1:5. Iodate, number of moles of iodate solution. So what is the concentration? 0.012 moles per cubic decimeter. Volume is, let us say, V, 10 to the power minus 3 cubic decimeters. Divide by iodide ions. What is that? 20.1. 0.1 moles per cubic decimeter times 20, 10 to the power minus 3 cubic decimeters. That is equal to 1/5. Right? So what is that? Cubic decimeters, these cancels out. They all cancel out. 10 to the power minus 3. 10 to the power minus 3 cancels out. What is V? V is equal to 0.1 times 20 divided by 0.012 multiplied by 5. The answer comes with milliliters, because we took V as milliliters. That's why we multiplied by 10 to the power 3. So 2 divided by, what is that? 0.012 times 5. You get your answer 33.3. Then is that what you get? The answer is not given there. But what is the answer that you got? What I got was 33.3. Anybody who has done it? They're looking at R, right? 33.3. Okay, you have done it. Well done. Very good. Okay. Very good. not cubic decimeters. This one. Good, got the same answer. Somebody asked me how the iodometric titrations is different from this one. I have discussed the iodometric titration. Iodometric titration means you are generating iodine and then titrate it with sodium thiosulfate. Iodometric titration means you determine the iodine, determine the amount of iodine. Right, okay. So 25 milliliters of potassium permanganate iodate solution was added to 15 milliliters of 15% solution. Ensure excess iodide ion. So that is not a limiting reagent. The other one is the limiting reagent. On acidification, the liberated iodine needed sodium thiosulfate to titrate it. So same equation, the same equation. Now I am going to copy it and then we will use the same equation here. Then it is easy, right? Now this is the way to generate iodine. That iodine is titrated with sodium thiosulfate. Iodine with sodium thiosulfate. Na2S2O3. Dakota, please look at, before joining the class all the time here, discussion, look at these titrations again and again. And you will remember it. And it will be very helpful at the later stage. It will be very, very helpful at the later stage. Right. The liberated iodine needed 24.1 milliliters of 0.05 molar sodium thiosulfate to titrate it. Right? So this solution has 25 milliliters. This says 15% anammanam kila thiyena, but that is to confuse you with lot of information and to overwhelm you. But then you guys are very cunning. You know what to take and what not to take because it says 15% ensure excess iodine. Excess iodide means that iodate is the limiting reagent. So this is the limiting reagent. Everything of this will react. Right. Okay. So let us look at this one. Number of moles of sodium thiosulfate to number of moles of iodine. Number of moles of iodine. Iodine is 1, sodium thiosulfate is 2. What is the number of moles of iodine? Number of moles of iodine is equal to 0.05 times 24.1 10 to the power minus 3 divided by 2. Right? So what is that? 0.05 times 24.1 10 to the power minus 3 divided by 2. That means 6.025. 10 to the power minus 4 moles of iodine is formed. Right? There is the number of moles of iodine formed. So if that iodine is formed by this reaction. Iodate reaction. So let us look at the number of moles of iodate that is present. Number of moles of iodate to number of moles of iodine from the first reaction. Right? I have done this titration. I have done this practically also, right, in the class. Iodate is 1, iodine is 3. Right. So what is the number of moles of iodate? Number of moles of iodate is equal to 6.025 10 to the power minus 4 divided by 3 moles. So what I did was I cross multiply this. So what is that? Divide by 3 is equal to 2 10 to the power minus 4. 2 10 to the power minus 4 moles. What do they ask? They ask you to calculate the concentration. So how do you calculate the concentration of KiO3? You know number of moles divided by volume. 2 10 to the power minus 4 moles divided by volume. What is the volume that you have taken? It says 25. 25 10 to the power minus 3. Right. So what is that? 2 10 to the power minus 4 divided by 25 10 to the power minus 3. 8 10 to the power minus 3 kilonewton concentration. 8 10 to the power minus 3 moles per cubic decimeter. But what do they ask? They don't ask moles. They ask in grams, right? Concentration in grams. So KiO3, potassium is 39, iodine is 127, oxygen is 16 times 3, 48. So 39 plus 127 plus 48, 214. Double check that answer, 214 grams per moles. So you convert it to this 8 10 to the power minus 3 multiplied by 240 grams per cubic decimeter. What is that? Multiplied by 8 10 to the power minus 3. I get 1.712 kilon. 1.712 grams per cubic decimeter. I hope you all got that answer. Everybody got it? Which is the limiting reagent? Iodate is the limiting reagent, right? Iodate is the limiting reagent. Is it okay to use the redox number method to balance? Yes, of course. As long as you get this, it's okay, right? Everybody okay with that? Right. So 1.712 is what you get. Right. It was say, what is the indicator used in the titration and what is the color change at the endpoint? I hope you remember what is the indicator that is done used in this titration. What is the color change at the endpoint? What is the indicator? Indicator when the color becomes really pale yellow in color, hay yellow or straw yellow in color. You add a few drops of starch. And then when you add starch, it becomes blue-black in color, bluish black in color, or blackish blue in color. Right? What is the color change? This bluish black color material turns into colorless. Bluish black color material turns into colorless. Everybody understood that? Clear? Right. Okay, so you've done some questions, huh? Right. Everyone know all right? I think I hope you understood this thing. Right. Now, like that is question number 14 as that is also done. Now within like another, I will discuss this tutorial for about another maybe 1 or 2 days, right? 1 or 2 days. I think complete කරන්න ඕනේ, right? Then I have to go into the gases tutorial because now the kinetic, the energetic tutorial is also out, so we need to discuss that one as well. I think I want you all to do it like now with from the way that I have done, move on forward, right? So if ideally, since the answers are given, uh, I would like to discuss the difficult questions that you all cannot handle. Right? Okay, right. But I'll give you another 2 weeks to actually go through that tutorial and complete it as much as possible. Right. Okay, so at this point we will stop. See you again on Saturday. Right? Right. Okay, Buddha. Bye. Good night.